Hello everyone, let's find out the energy stored by a parallel plate capacitor. So, the work done to transfer electrons from one plate to another is stored as electrostatic energy in the electric field between the plates of the capacitor. To understand this, let's consider capacitor plates. Let us take two parallel plates and then let us connect this to a battery. Suppose a battery which offers a potential difference of V. So in this case, when you connect them, then what happens is, we call as plate 1 and plate 2, the plate 1 is connected to the positive terminal. So electrons will be pulled by this potential. So electrons will start to move from here. They'll cross the plate and go into this side. So electrons will be piled up on this side. Now since electrons are left the plate 1, the plate 1 would be charged positively, because if electrons are removed, it becomes charged positively. So the current flows from the battery from the positive terminal. Let V be its potential in this case. Now this work done by the battery. Now the battery is the one which is doing work to move the electrons. The electrons have been moved from plate 1 to plate 2. So this work done by the battery is stored as electrostatic energy in the fields. Recall that we have studied that electrostatic field stores the energy. So the work done by the battery is stored as energy in this field. So we need to find what is energy stored in this capacitor field. To understand this, let the maximum charge on this be capital Q and let V be its maximum potential difference. For example, let's take a battery of 5 volt, and for this capacitor C, let the charge be some 5 microcoulomb. Now when you turn on the battery, the potential difference will not become 5 volt instantaneously. When we turn on the battery, the voltage drop will increase from 0 to 5. It will be like 0, 0.1 volt, 0.2 volt. It keeps on increasing. So at some point, this happens very instantaneously. Imagine at some point, the potential difference between the two plates is some small v. Example, imagine it's like 2.3 volt, some random value. As time goes on, charge builds up here. So let the potential drop between the plates 1 and 2 be small v. At that time, let the charge on the plate be Q. For example, think of Q as 2.3 microcoulomb. So when the voltage is 2.3 volt at some point of time, then let the charge on this be 2.3 microcoulomb. Keep in mind that the charge is building up to 5 microcoulomb. So it will take some time to build up to 5 microcoulomb. Now in this case, at this moment, charge is Q. Let charge be displaced by dq, that is, let a small amount of charge dq flow from here. So the work done in this case we call as dw. So dw is the work done for the small displacement, and we recall that work done is given as charge moved into potential difference. So in this case it will be dq into v. That is because we are moving a charge of dq. The work done is dw. Example, think that dq is like 0.001 microcoulomb. So we are doing work to move this charge. That is called as dw. Now we know that v is equal to, or q is equal to c into v, or v is equal to q by c. So at this moment, the work done we can write as dq into v, and v is given as q by c. So this is the work done for small moment. Recall that small v is not same as capital V. Capital V is the maximum potential difference possible. and small v is at some value. Now we need to find the total work done, not only for this dq, we want to find the work done to build up a charge of 5 microcoulomb. So the total work done would be adding all the small amount of work done. Understand this? Think of a water tank like this. Suppose imagine that we need to fill water up to a capacity of 500 liter. So we can't fill 500 instantaneously. It takes some time. It'll keep on building up. It'll be like half a liter, 1 liter, keep on building up. So at some point imagine that this tank contains a water of say 150 liter at some point of time. We need to build up to 500 liter. Now imagine that we add some more water to it. So make it like 150.1 liter. So this 0.1 liter is extra water added. Same way, the charge is small q, the work done to move some more charge, we call it as dq. That work done is given as dq into v. So we want to find total work done, which means we want to find adding all the small amount of water is doing here. Same way in this case, we want to find what is the work done to the entire charge. So that the work done is nothing but integrating this, because you want to find for the entire charge being built up here. What's the range of q? Initially, when we started with the charge building up, the charge was 0 on the plates. So the range of q, the limit of q starts from 0, and we want to build up to capital Q. So it goes till capital Q. Therefore, the work done here is equal to 1 by C is a constant, because for given capacitor C remains a constant. We need to integrate this term 0 to capital Q, Q into dq. It's 1 by C. Integrate this, it becomes q power 1 plus 1 by 1 plus 1, 0 to capital Q. And this is equal to 2 comes out because 1 plus 1 is 2. So it becomes 1 by 2C. It becomes Q square. The limits are capital Q and small q. Let's put the values. It is equal to 1 by 2C. Upper limit minus lower limit. 0 square is same as 0 only. It is equal to Q square by 2C. Now this is the work done. But recall that we learned that the work done is always stored as, in this case it is stored as the system's potential energy. Therefore, what we get is, therefore the work done is stored as the system's potential energy. Therefore U is equal to Q square by 2C. So this is the work done to build up a charge of capital Q. We can write this in other form also. Here this U is in form of Q and then C. We can write U in form of something else also. For example, Q is equal to C into V. We put it back here. We get U is equal to CV the whole square by 2 into C. That is equal to C square V square by 2 into C. So from here 1 C gets cancelled. And therefore what we get from here is U is equal to half CV square. This is other form of U. Also recall that we can write C as Q by V. To put it back here, we get U is equal to Q square by 2 into C becomes Q by V. So it becomes Q by V. This V goes on top. It's Q square by Q square into V by 2Q. From here 1 it's cancelled. Therefore this is equal to QV by 2. So these are different forms of the energy. Learn anyone, learn this form alone, because these two forms come from here only. So just learn this form alone. And keep in mind that this energy is stored in the electric field between the two plates.